Hello. In today's video, we're going to start chapter 2, and specifically, we're going to talk about frequency distributions, right? When we get some sort of organized data, we want to know how can we visualize this? How can we somehow make it easier to look at? And so often what we'll do is we'll construct these statistical tables to help us. And what these tables will do, and one of the words that will come up in later chapters that's really important, is displaying the data this way will help us see the data distribution or the shape of the data, right? The distribution of our data set will be really important when we go to make inferences on it. If I know how it's distributed, I can make better and better inferences. So we're going to break this down for the different pieces of data. So we'll start with qualitative data, right? Again, qualitative data is just the categories like hair color, eye color, uh, jersey number, city you were born. The problem is there's really no measurability with those categories. The only thing we can do in kind of the namesake of the section is talk about the frequency, right? How frequent is this data seen? And really we kind of organize this in three ways. We can look at it just by the frequency of the measurement, right? How many tallies can we have for each category? Next, we might want to know, well, what is the relative frequency or what is the proportion or probability that that category is seen in the data? And then the third is the percentage of measurements we might see. What percent of people in this class were born in Pennsylvania versus born in New Jersey versus born outside of kind of the mid-Atlantic region. And frequency is just kind of our total count. If I want to look at relative frequency, to find relative frequency, I'll just take the frequency and divide it by n, our total number of things. And then this is always going to be a decimal or fraction. Right? Always a decimal or fraction between 0 and 1. Right? And to find a percentage, of course, we're just going to take, to find our percentage, we're just going to take our relative frequency that we just found and multiply it by 100. And if we create this thing correctly, what will happen is if we add up all the frequencies of our categories, they should add up to the total number of data points I have, right? If I'm going to break all of the data points up in a sub number of categories, every item should go into one category, and every category, the total of all those categories should contain every data point, right? The sum of my relative frequencies should add up to 1. The sum of my percentages should add up to 100%. And kind of a restating of what we just said, any measurement will only belong to a single category, and each measurement has a category to belong to. This kind of says nothing's repeated, right? Everything is in there once, and this is everybody has a home, right? There is one place for somewhere to go. So let's kind of practice building a frequency distribution. So listed below are counts we may have gotten for grades in a particular class through every section, right? So something like this section, like 208, we offer a lot of sections of it through the year. So maybe we want to tabulate how students are doing. So we find out that there are 35 A's, 260 B's, 93 C's, and 12 D's. And what we want to do is we want to complete a frequency distribution or a frequency chart to find the relative frequency and the percentage of each piece. Okay, so let's do that. So what we can do is we can have kind of a chart built, and what we'll do is we'll talk about the frequency. So I kind of think about building a chart this way, where the columns are the different things we want to know. So the first column is going to be my label, kind of the A, B, C, or D. The second column here is going to be my frequency. This is kind of what we get directly from that data set. And if we look, we add, there's 400 students in this search. The third column is our relative frequency, and then our percentage. right? To find our relative frequency, we'll kind of work down here. If I want to find the relative frequency of the A's, we just said all we have to do is take our frequency divided by the total, right? So 35 divided by 400. If I do that, my relative frequency is 0.0875. So I'll put that 0.0875. My B's is going to be 260, 260 divided by 400. This is going to be 0.65. So that's my relative frequency of B's. C is going to be 93 over 400, or 0.2325. 0.2325. And lastly, my D's 12 over 400, or 0.03. And in fact, if we added them all up, we would in fact get 1. Our percentages, again, we're just going to multiply each of these relative frequencies by 100. And again, multiplying a decimal by 100 is the same thing as just moving it over 2 spots. So percentage here is going to be 8.75. 65, we'll put a little percent sign next to all of these. 23.25%, and then 3%. And again, if we add all of those values up, we would in fact get 100%. Next, we can look at graphs or charts or ways we can talk about quantitative data. And pie or bar charts really kind of still work, but there are really better ways to represent numerical data that we can have besides pie and bar charts. Many sets of quantitative data consist of numbers that really cannot be separated into categories. That's one of the big problems with these things. We might have lots of different numbers that have a wide range. And so kind of putting them into some of these categories might be difficult. So one way we can do this is what we call a dot plot. Right? In a dot plot, we plot measurements along some sort of horizontal axis and use actual dots or little X marks to represent the frequency. And so what we could do is we could take a data set like this, some example of a data set of 269, 376, 445, and represent a dot plot. And so what we're going to do is we're going to list the values 2, 3, 4, 5, 6, 7, 8, 9, kind of put a horizontal bar. We'll put, little physical X's every time I see one of those. So I see a 2, so I'll put a 2 there. Next, I see a 6, I'll put an X next to a 6, 9, 3, and 9, 3, 7. And when we get repeated, we just go vertical, right? So 4, 4, 5, so 4, 4, 5, right? This would be our dot plot for this case. And so we still get a representation. If we wanted to, we could still kind of sketch this curve out. All right, that's a little bit ahead of, but we would get, this is what we mean by the shape of data. And we can kind of see there are kind of two, in this case, there are two, we would say this is, specifically, we would say this thing is bimodal. Right, so in future statistics classes, you might take it in a graduate course or something like that. Even the shape of data like this would be still kind of important. But often in graphs, there is a give and take, there's a trade-off. And so if we look at this, right, it is a way to represent the data rather than just, right, it still shrinks it down a little bit, right, every repetition, right? So when we repeat 6s, we just some vertical spot. The problem is our give and take is between precision and presentation, right? This graph is really precise. It tells me exactly how many of each data point I have. The problem is, if this graph, right, this is just kind of a workable set of data. If this was an actual kind of set of data, if you're talking about like patient histories or maybe temperatures of patients, there might be thousands of temperatures. A dot plot would not be very good to represent thousands of temperatures, right? You can imagine the heights of some of these would be really large, and we would have a really wide range of values because you could have a whole slew of different body temperatures. So one way we can kind of break down the precision but increase our viewability or our presentation is by using what we call a stem plot or a stem and leaf plot. In a stem and leaf plot, there's really kind of 5 steps. We're going to divide the data into 2 parts, what we call the stem and the leaf. Usually what we do is we break a 2-digit number by the tens place and the ones place. Usually it's like the tens place and the ones place are the stem and the leaf respectively. We're going to list the stems in a column vertically with kind of a line to their right. And then for each data point, we're going to record the leaf portion in the same row as its corresponding stem. So if we get a data point, let's say of 34, we're going to have part of our chart that looks like this. We would write it like this. So we would know to the left of the bar is going to be our tens place. To the right of the bar is going to be our ones place. So we would read this value as 34. And we do that for each data point. What we want to do is we want to sort each row. I kind of think about building stem and leaf plots in 2 steps. We just kind of build the stems and then put the leaves down when we can, and then we'll sort them. And then we kind of want to provide a key for the scale. And this key really represents what is to the left of the stem. And so we'll see what that means. So we want to construct a stem and leaf plot for these 2 sets of data. All right, we're going to kind of do this one at a time. So for this first set, we have like 90, 70, 70, 75, and so on. And for part B, we're going to have something like 7.2, 7.8, 6.8, and so on. And so for part A, we can see just kind of a natural stem position is the tens place. And so what we'll do is we'll put this kind of vertical line down, and then I will list kind of a descending order all of the different tens. So we have values in the 90s, the 80s, the 70s, the 60s, the 50s, and the 40s. What we don't want to do is we don't want to skip any of these, right? Even if none are present. Let's say this data set had no 70s. We still wouldn't want to skip it. We would still want to put that there, and we would just have an empty leaf plot over here. So if we start filling it in, right, I'm not going to keep looking up and down, but we can see what I would do is I would look at our data set. And if you want to pause this video and kind of go back to it or look at the notes we have kind of elsewhere in Blackboard, I'll just start putting these in the order in which they appear. Right? And so this is what we mean by having unsorted data at first. Right? When I first do this, I'm not worried about whether these rows are in numerical order. All I'm worried about is whether I get the correct, I get the leaves in the corresponding stems. So for example, this 90, I put that 0 right there. Right, this 70, I'm going to put that 0 there. That's kind of where it goes. That's how we build this thing. And so the next thing I would do now, right, to kind of finish this, I have the benefit of copy and paste. So I'm just going to copy this, paste it, just move this down a little. And once I have the rows complete, I'll make sure they're sorted. So the 90s row is sorted. The 80s and the 50s row are already there. The 70s row, let's see, there's 1, 2, 3, 4, 5, 6, 7 zeros. So 1, 2, 3, 4, 5, 6, 7. And then I have a 4 and 2 5s. 60s, I have a 0, 3 5s, and then 2 8s. then a 0. And then say is our key, the stem is equal to 10, which tells us everything to the left of this stem is going to be somewhere on the tens place. All right, let's do one more. Let's look at part B. If I look at my data set in part B, it's going to look kind of similar. I'm going to have 7, 7.2, 7.8, 6.9, and so on and so forth. So what I'll do is I'll still put the stem down, but now the numbers that go down here in my stem are going to be the ones place. They're going to be 9, 8, 7, 6, 5, 4. And then I'll start listing them unsorted, right? So we get like 72, 78, 7.2, 7.8, and then we'll just start listing them unsorted, so we don't keep going back and forth. 8, 2, 3, 5, 7, 7, 46. And so once we have our kind of unsorted list, I want to make sure I can sort this. So we get 1 and 4, 0, 3, 8, 2, 3, and 8, 2, 3, and 8, 5, 7, 7, 6. And here, our key would be that the stem is equal to 1.0. And that tells us that these values are not 91, but they're actually 9.1. That this is the ones place, and then this must be the first decimal. Right? That's how we would read that.